Think back to the height of the COVID-19 pandemic. You probably saw those images from inside ICUs everywhere. And amid all the blinking machines and ventilators, there was this one really strange scene that kept popping up. Patients lying on their stomachs. It looked odd, almost a last-ditch effort. But the truth is, it was saving lives. So what's the deal here? How can a maneuver that seems so simple, so low-tech, actually save someone's life when they are that critically ill? Well, that is exactly what we are going to break down right now.
All right, so to really get why prone positioning works, we first have to understand the problem it's trying to solve. And we're talking about a type of severe lung failure that, thanks to the pandemic, pretty much became a household name, ARDS.
With ARDS, the lungs get so inflamed and damaged that fluid starts leaking into these tiny little air sacs called the alveoli. So think of your lungs like two big sponges. They're supposed to be light and full of air, but with ARDS, they become completely waterlogged. And here's the really scary part. Even when you have a machine, a ventilator, literally forcing oxygen into the lungs, that oxygen can't get across the fluid barrier to get into the blood. The body is literally starving for oxygen, and our most advanced technology is struggling to fix it. So when the high-tech ventilators are hitting a wall, what do doctors do? They turn to something, well, surprisingly physical. Yep, it's called prone positioning, or proning, in an environment that is just buzzing with monitors and pumps and all kinds of complex circuits. One of the most effective tools in the entire playbook comes down to basic physics and physiology. Okay, this is where it gets really fascinating. Why on earth does just flipping a patient from their back to their stomach make such a massive difference? Well, it all comes down to three simple things: gravity, weight, and the way our chest is built. So we're going to compare two positions. First, you have supine, which is just lying flat on your back, and then you have prone, which is lying on your stomach. And for a patient with sick lungs, the difference between these two is honestly like night and day. See, when a patient is on their back, it's like a perfect storm of bad things happening in their chest. Gravity pulls all that fluid down into the back of the lungs, which also happens to be the biggest part. Your own heart sits there like a paperweight, just squishing the delicate lung tissue right underneath it. And to top it off, the abdomen pushes up, squeezing the lungs from below. The result is just a compressed, fluid-filled mess where oxygen can't get in. But now, watch what happens when you flip the patient over. It's amazing. Suddenly, everything that was working against the lungs is now working for them. Gravity helps drain the fluid away. The heart now rests on the breastbone, getting its weight off the lungs. And those parts of the lung in the back that were all squished before, they're now on top, and they can finally pop back open and fill with air. It all leads to better VQ matching, which is just a fancy way of saying we're getting air to the same place the blood is flowing. It's a huge deal. And this isn't just a theory. The real-world numbers are just staggering. One big study on COVID patients with severe ARDS found that 77% of them were prone responders. That means for more than 3/4 of them, their oxygen levels shot up after being turned. This wasn't a small change, it was a total game changer. And look, this isn't just about a temporary oxygen boost. We're talking about survival. The huge PROSVANA trial proved this years ago. For patients with severe ARDS who were kept on their backs, the mortality rate was almost 33%. But for the group that was prone, just 16%. Let that sink in. They literally cut the death rate in half. Another way to look at it is the number needed to treat. To save one life, they only had to prone 6 patients. Let me tell you, in medicine, an NNT of 6 is, well, it's a home run. It is an incredibly effective intervention. Okay, so the concept is simple, right? Just flip them over. But actually doing it? Oh man, it is anything but simple. This isn't like rolling over in your sleep. This is a high-stakes, highly choreographed medical procedure. It takes a whole team, 5, 6, sometimes 7 people. Nurses, respiratory therapists, doctors, all moving as one. Every single line, every tube, and especially that critical breathing tube has to be perfectly secured. The turn itself is like a slow-motion ballet, where one tiny wrong move could be catastrophic. And of course, you can't do this for every patient. If someone has, say, an unstable spine, or really high pressure in their brain, or big open wounds on their chest, proning is just too dangerous. It's a powerful tool, but you have to know when not to use it. And yeah, the risks are very real.
The absolute number one fear is that breathing tube accidentally coming out. But you can also lose IV lines. Patients can get terrible pressure sores. It's a long list. It's honestly a huge testament to the skill of ICU teams that they manage these risks so well, allowing the life-saving benefits to shine through.
So let's zoom out. When you put it all together, what's the big takeaway from all this? What have we really learned about this simple yet incredibly powerful idea?
You know, this quote from a key study really just nails it. It basically says, proning helps the lungs expand and get oxygen to the body for the vast majority of these critically ill patients. It's not some experimental, fringy idea. It's a core, evidence-based therapy.
And for me, that's the coolest part of this whole story. In our rush for new drugs and futuristic gadgets, it's easy to forget the incredible power of just working with the body's own design. Proning is just a perfect, elegant example of using basic science to get an absolutely profound result.
It really makes you stop and think, doesn't it? As we keep pushing the boundaries of medicine, you have to wonder, what other elegantly simple, life-saving ideas are just sitting there, hiding in plain sight, waiting for us to rediscover them?